Okay, let's talk about algebra of functions and function composition. Now, first off, you're going to see f of x and g of x notation. G of x and f of x, they're the same thing. They do not mean to multiply. They just mean f is one function and g is another. They're nothing but expressions. So, when you see sum, difference, product, quotient, what you're going to see it written like this: f plus g and then the x. That's not times. That just means that your function has the variable x in them. Both of them do. And all you're going to do, you're going to separate these two functions and add them together, subtract them, multiply and divide. So keep that in mind. All we're going to do is separate. So just for a review, f of 3 just means you'll use the f function. This f just tells you that we're going to use the f function. I mean, that's all it really is. And we're going to use the expression that it equals. So 3x. That means we're going to take 3, and rather than using the x, we're going to use the 3 that we're going to substitute based on what's given in the parentheses. So 3 times 3 is 9. Now, I easily could have asked you to find g of 3. Now, g of 3 means use the g function, which is the square root of x minus 2. But rather than x, we use the 3. So 3 minus 2. And the square root of 3 minus 2 is the square root of 1. That equals 1. So that's all the f and the g mean, and the number beside it does not mean multiplication, it means substitution. So now let's get to what this section is actually about. In this case, the sum of two functions. So we're going to find f plus g of 6. That is not multiplication. What that is, that means you find f of 6 first, find g of 6, then you add those two together. So there's a couple ways you can approach it. You may want to do it as two separate problems and add those two answers together, and you may want to do it all at once. Just show you one way to approach it. You may want to just do this. We're going to do f of 6 first, which means we're going to use 3x. 3 times x is the same as 3 times 6. And 3 times 6 is 18. And then we have g of x, which is absolute value, or square root of x minus 2. So we're going to take the absolute value of x minus 2 and replace the x with the 6. And square root of 6 minus 2 is square root of 4. We're just going to move it on down. Maybe we can fit it in. So the square root of 4 is 2, and then 18 plus 2 is 20. So we're saying that f plus g of 6 is equal to 20. Now we're going to do a couple more examples, and this time we're going to use x. Remember, we're using the same two functions. I'm going to write them down here so I won't lose them, and you'll know what I'm looking at. So this fg, that's the same as f times g. So that means we're going to find f of x times g of x. Now f of x is given to be 3x, and g of x is given to be the square root of x minus 2. Since we can't multiply a number that's not under radical to one that's under the radical, the final answer is just 3x times the square root of x minus 2. And we're done. Now this divide means we're going to find f of x divided by g of x. Once again, since these are in terms of x, or x's, we're going to leave them as they are. So f of x is the 3x, and that goes on top. G of x is square root of x minus 2, and that goes on the bottom. Now what we're going to do, we're going to find the domain also, but we're done with f divided by g of x. That's the actual answer. Now we need the domain. Now when we find the domain, there's two things we have to consider. First thing is that we have the x minus 2, which is underneath the radical. So that means x minus 2 has to be greater than or equal to 0. But if you notice, and the reason why that is because we can't take the square root of a negative number. We're working on the real number system. But if you also notice that this absolute value of x minus 2 is a denominator. So that means that x minus 2 has to be bigger than 0. So this is what we're going to look at, x minus 2 greater than 0. So we're going to add 2 to both sides, and we get x greater than 2. So the domain, which I'm going to use interval notation, is parentheses 2, comma, and then everything bigger than 2 goes to infinity. Now if you want to see the graph of that, well, just graph it. So when I type this in, I want to put the numerator in parentheses, 3x, divided by the denominator also in parentheses, just to be safe. It never hurts to be safe. And we're going to graph it. And you see that, which doesn't tell you much. But if you take a good look at it, it looks like it's getting closer and closer to 2 on the left side, but doesn't get there, and it goes further to the right. Now the only question is about that number 2. Is it included or is it not included? One thing you can do is hit trace 2, enter, and you don't see an answer there like you do with 3. See that? But with 2, you don't. That tells me that when you substitute 2 in, we don't get an answer. So we can't include 2. Another thing is we can hit second graph, which is a table, and you'll see a bunch of errors. In fact, everywhere from the left, see that, are all errors. But when we get to negative 2, there's still an error. When we get to 1, and we get to 2, there's still an error. And then 3, there's not. And so if you want to be sure if it's going to 2, but really close to 2, if you hit like 2.1, you're still going to get an answer, but you won't for 2. So everything is telling you that it's from 2 to infinity, the 2 not included. I'm going to erase this so I can have a little extra space so you won't get confused with the next example. You can always rewind the video if you need to look at that again. It's not going anywhere. Now let's do f minus g of 11. Notice I said of 11. That means we're going to find f of 11. We're going to find g of 11, and we're going to subtract the 2. Once again, my two functions, f of x equals 3x, and g of x equals square root of x minus 2. That's our two functions that we're still using. I'm going to do it like this. I'm going to go ahead and find f of 11. F of 11 is 3 times 11, which is 33. And then g of 11 is the square root, because this is my g function, of 11 minus 2 equals the square root of 9, which equals 3. So to find our answer, you can like mark this off a little bit and see that f of 11 minus g of 11 is the same as 33 minus 3, which is 30. That's our answer. So f minus g of 11 is 30. In this last example, you're given a graph to represent the two functions f and g. F is this one and g is that one. If you can see, f is the red one, g is the blue one. So we're going to just do a couple of these. You're asked to find f plus g of 1. So that means we need to find f of 1 and find g of 1, then add those two together. Now all f of 1 means is to find the y value when x equals 1. So we're going to go to x equals 1, and we're going to go up to the f function. F is red, so it's right here. And so that y value is 1, 2, is that 1, 2, 3, 4? It's 4. In fact, if you were to label that point, that would be 1, comma 4. So when x is 1, y is 4, in this case f. See y, you can write y as f of x now in your grid, or you can also use g of x, because we're going to use that to find g of 1. So once again, we're going to go over to x equals 1, and then we're going to go up to the blue, because that's our g function. And that point is 1 comma 1, because that y value is 1. So g of 1 is the x value, or equals the y value, on g, where x equals 1. So when x equals 1, g, the y value was 1. So when we add those two together, we get 5.